Here is one of the most terrifying unsolved mysteries in all of physics. When the universe was born 13.8 billion years ago, equal amounts of matter and antimatter were created. And antimatter is exactly what it sounds like, it is the mirror opposite of regular matter. When the two touch, they annihilate each other completely, converting entirely into pure energy. So here is the problem. If the Big Bang created equal parts of both, they should have destroyed each other completely. The universe should be nothing but a vast ocean of light and energy. No stars, no planets, no galaxies, no you. And yet, here we are. Something survived. And physicists have been losing sleep over this for decades because we genuinely do not fully understand why. This asymmetry between matter and antimatter is called CP violation, and it is one of the biggest open questions in modern science. In 1967, physicist Andrei Sakharov laid out 3 conditions necessary for matter to dominate after the Big Bang, and CP violation was one of them. We have confirmed that CP violation exists. The Large Hadron Collider at CERN has been smashing particles together since 2008, and experiments there have directly observed antimatter behaving slightly differently than matter. In 2019, the LHCb experiment detected a difference in how particles called d mesons decay compared to their antimatter counterparts. But here is the frustrating part: the amount of asymmetry we have measured so far is not nearly enough to explain why we have an entire universe full of matter. The imbalance we see in our experiments accounts for maybe 1/1000th of what would be needed. So somewhere out there, there is a mechanism we have not found yet. One candidate is something called leptogenesis, the idea that early in the universe, heavy particles called neutrinos decayed slightly more often into matter than antimatter, tipping the balance. The problem is we cannot directly test this yet because it would require energies far beyond anything our current colliders can reach. Another fascinating angle came in 2020 from Japan's T2K experiment, which fired neutrinos and antineutrinos toward a detector 295 kilometers away. They found strong hints that neutrinos and antineutrinos behave differently, which would be a massive clue pointing toward leptogenesis. The result had a confidence level of about 95%, which is promising but not yet the gold standard 5 sigma proof physicists require. CERN is already planning the Future Circular Collider, a machine 91 kilometers in circumference, 3 times larger than the LHC, potentially operational by the 2040s, which could finally push us into energy ranges where this mystery starts unraveling. Now, why does this matter to you right now, today? Because antimatter is not just a theoretical curiosity. PET scans in hospitals use antimatter, positrons specifically, to image your brain and detect cancer. Antimatter propulsion is seriously discussed by NASA for deep space travel because annihilating just 1 gram of antimatter releases the energy equivalent of a 43-kiloton nuclear bomb. The reason we exist at all comes down to a tiny 1 in a billion imbalance in the early universe. You are quite literally the leftovers of a cosmic annihilation event. Every atom in your body survived because matter edged out antimatter by the thinnest possible margin. And we still do not know exactly why. That is the kind of question that keeps physicists awake at 3 a.m.